Previously, I said process control information includes process state. In the world of computing, processes go through different states, and each states represent a specific condition or stage of execution. These states and their transitions are essential because they help the operating system manage and monitor the progress of processes effectively. So by understanding the current state of a process, the system can allocate resources, schedule processes, and ensure efficient and productive utilization of the CPU. So let's start with a new state. Firstly, there is this state where a process is just being created. It's like a new task being initiated. Operating system need to set up necessary details, but the process hasn't started executing it yet, okay? Often due to limited resources. Another state is ready. A process in the state is all set to start working, but it's waiting for the computer to assign it to a processor. It's ready to be executed, just waiting for its turn. Then it moves to the running state. In the state, the computer is actively following the instructions of the process. Like when you are actively working on a document, the process is actively being executed and utilizing the CPU. Only one process can be in this state on a single CPU at any given moment. So next, there is the waiting or blocked state. Here, the process is on hold, waiting for something specific to happen, like the completion of a download or receiving a signal, or it may wait for I/O operation to be completed. Lastly, we have terminated state. This is when the process has finished its execution, it's done. It's like completing a task and putting it aside. When the data is no more needed, the process and its table gets deleted. Okay, so let's consider a simple diagram with three process states, ready, running, and waiting, and explore four possible state transitions. So when a process is ready to execute, okay, the dispatcher, a part of the operating system, selects it, okay? So scheduler picks this process. So it selects it to run on the CPU. A process which is in the ready state is selected by the scheduler to execute. Now this process is currently using the CPU for its task, and it's on the running state. You can imagine several tasks waiting for their turn. When it's time, the operating system chooses one task to start working, okay? And when the running process issues an I/O request, such as reading data from a disk, the process transitions from running to waiting, okay? So process blocks for input. So the process requests something that it cannot get immediately. This could be waiting for not only for initiating I/O requests, but also for a service the operating system isn't ready to provide, or maybe access to a resource that is currently unavailable, or in other case, it may wait for input from another process. So it's similar to a person waiting for a response to an email before they can proceed with their work, okay? From waiting to ready, the state transitions from waiting to ready, indicating the process can now continue its execution since the required data is available. So we can say that input becomes available. So imagine a download completing, the process was waiting for it, and now that is done, the process is ready to continue. And we may also go from running to ready, okay? The process transitions from running to ready, allowing the scheduler to select a new process to run while the current process moves back to the ready state and waiting its turn again. So it's when scheduler fix another process. So maybe the time quantum of the running process expires in a preemptive scheduling system, or it gets interrupted because a higher priority process is ready to run. You can imagine this transition as a chef is preparing a dish, okay? So it's in running state. Suddenly a new order for a different dish with high priority comes in, okay? So the chef temporarily stops working on the current dish and making it ready to resume later and starts preparing the new high priority dish. So these state transitions illustrate how processes can move between different states based on specific events. Before concluding this part of the lecture, I want to emphasize on two things. Okay, so it's important to note that these names, the state names, might differ across different computer systems, but the states they represent are found on all systems. Also, you may see additional states names as like suspend and ready, suspend wait, something like that, as you can see in these figures. So also remember that at any given moment, only one process can be actively running on a processor. However, there can be many processes ready and waiting their turn, okay? So we see only one process in a running state. And we also see many processes on ready and blocked states.